We'll stop asking you what the difference between MEO and GEO, we promise, in board meeting.
I appreciate that. I'm Elliot from Redpoint Ventures, joined by my partner, Sai. We're here with Karan Kunjur to talk about K2 Space. Tell us a little bit about K2 Space and what your company does.
So I started this company 3.5 years ago with my brother, Neel. Neel was an ex-SpaceX engineer. I'd helped build a machine learning company. And we started K2 on a contrarian bet. Historically, everyone was moving smaller as it relates to space, building smaller satellites that were low cost, that could operate in the kind of the easiest environment was called low Earth orbit. And we said that was interesting and that was great for the 2010 to 2020 period, but the future was actually the opposite direction, building larger satellites. And not just incrementally larger, but so large that the smallest satellite we'll ever build is as large as the largest satellite that's ever existed. We're building the highest power platform that can be deployed in any orbit, and eventually will be deployed in every part of the solar system moving forward.
Maybe talk a little bit about some of the technical challenges that you are going to have to overcome.
The number of engineering challenges we've had to take on is far greater than what we expected, and it all comes back to just doing a reset. Resetting satellite design, the launch vehicle performance of today versus what you optimize for historically.
So you're starting with the MEO orbit. Maybe you could give a quick overview on why you think that's a good starting place.
MEO has been historically a very difficult orbit to operate in. You need to have a lot of radiation tolerance. You need to have a lot of propulsion to be able to get there, or you need to use full dedicated launch vehicles, which is like highly inefficient. But if you could get there, you actually had some benefits where for MEO, the number of satellites you need to get global coverage is only like 20, while LEO, the number of satellites you need is anywhere between 500 and 1,000. So there's some really interesting economics and capabilities you can do from MEO that historically no one had gone after because it was just so hard to operate in MEO. We're now opening up that orbit in a way that nobody else can.
When you dream the dream, in 10 years, what will K2 Space look like?
I really see our satellite being used for humanity's expansion from LEO to MEO to GEO to cislunar space and then beyond. By tackling MEO, a super hard radiation environment, we've kind of already tackled a lot of the same challenges you need to go do deep space missions. We're scaling up pretty quickly, and we really will look at success based on how many different applications are being built off of the K2 satellite.
You've got a big mission coming up next March. Can you help us understand what's happening and what success will look like?
Yeah, so we had to basically go redesign the satellite from scratch. Like 80% of the systems that are flying in March of 26 are brand new and haven't operated in space. We're going to be firing the high-powered thruster for the first time in space. We're going to be testing out the deployment of the massive solar arrays and whether that works. We're going to be testing out the large reaction wheels, the high power systems, the batteries, the flight computer. There's a massive amount of new systems that are going to be operating. And so for us, we're really excited to just collect data. Like you can do all the testing you want on the ground, but part of what we wanted to do was get on orbit as fast as possible to be able to collect a lot of data in terms of on-orbit performance. And I think we're going to learn a lot from this first mission.
Hey, Karan, what are the new use cases you open up with K2 Space? What can we do now that wasn't possible before?
What I see in the future is almost everything we do from a communications perspective on the ground, we can now do from space. Almost everything we do from an RF sensing on the ground or in the air, we can now do from space. Almost everything we do from a compute perspective on the ground, we can now do from space. And that's kind of the underlying thesis. Like we see a number of these applications picking up at different periods of time over the next 5, 10, and 20 years. But all of them are going to require a lot of power, a lot of compute, and a lot of capability. And we expect that to be built off the K2 satellite.
We're really excited to be investors in K2. We fell in love with the thesis that bigger is better for satellites and that launch costs dropping made large and powerful satellites feasible. In addition to commercial opportunities, we believe geopolitical dynamics make K2's applications particularly important to the US military. We were floored by the team. The combination of commercial and technical talent really impressed us, and the talent that they're hiring from SpaceX and other top companies and the government was a signal. It's really hard to actually do technical diligence for this type of company, but if you track the smartest people on a domain and see where they're going, it can be very telling as to where the opportunity lies. And we saw that in spades with K2. So we are huge believers in what they're doing, and we think it's going to be a massive company, and we're so excited to be along for the ride.